is Tuesday, and it is Tech Tuesday, IAEI News Live. We're talking about, so I'm cheating. Just telling you right now, I'll tell you like it is, I'm cheating today.
It's Tuesday.
Whoa, hold on.
And
hold on.
It is...
Sorry about that. I had it open in the background and it just started playing. So anyway, we're live today. Mr. Robert from Omaha, it has started. I am live. And hopefully you can see it. So today I'm cheating today. I am breaking two windows with one stone. I was given a task. I'm on a task group, and we are working on the next edition of the National Electrical Code. And we're looking at two new terms. So today on IAEI News Live, we're talking about the branch circuit overcurrent protective device, and it all starts now. All right, get your coffee, your beverage of choice, your water. We're going to get, we have a job to do. And so what I want to do in this session is I want to basically walk you through the task group work that I need to get done. And I'll tell you what it is in a second. But I wanted you to be a part of this. So I am going to be watching the chat. We got Robert, we got Don Gannier. All right, Don, Mr. Research, I need your help, buddy. And David Engelhart are going to need you as well. So Eli Markovic, howdy. Eli Markovic, what country? Where's your heritage? I'm Croatian. Just found where my grandfather was born in Croatia. My cousin is out there right now. He visited the church that my grandfather was baptized in. So big Dimitrovich moment. So anyway, Redondo from Costa Rica. We will see you soon, hopefully. Don Gannier. I know the term comes from the product standard, but it's very confusing. Yep. So this is what we're talking about today, guys and gals. We have the desire to address this language. I don't know why that didn't work. All right. Maybe I got the wrong monitor. I don't know what's going on with my monitor. Anyway, what we're talking about is the definition in the National Electrical Code for a branch circuit overcurrent protective device. It says that it's a device capable of providing protection for service, feeder, and branch circuits and equipment. So that right there, that's the first sticking point, Dawn, that a lot of people have in regard to this discussion is you'll hear the debate that how can a branch circuit overcurrent protective device provide protection for a feeder or for a service conductor or transformer secondary conductor or a photo PV output source conductor, right? So there are a lot of different examples of how the term overcurrent branch circuit overcurrent protective device doesn't sort of align. And what's really interesting is if you search the code, like I'm going to do a search on NFPA link for through the entire code. I'm going to search for branch circuit overcurrent protective device. Let me see if I can do this. Let me show you something. I'm going to bring this over here. And it's still not showing it. I don't know why it is not doing that. But let me just fix this. Go to display, monitor 1, properties, copy, filter, add. I'm not sure. Screenshot, filters. I don't know why it's not giving me my my actual monitor 1. That anyway. So when I search the code, there is the use branch circuit overcurrent protective devices in 240.24b2. There's a 430.72b2 branch circuit overcurrent protective device in 430.72b2. There's the definition. And I think that's it. So, in 445, it's there as well. The listed branch circuit overcurrent protective device. So there are some places where that term is being used. The task group originally was saying that it's not used, and technically, I'm seeing where it is used in a few locations. So here's a good example, 225.42. 225.42b location says, now remember, 225 is outside feeders and branch circuits. So 225.42 is surge protection, and it says this SPD shall be installed in or adjacent to the distribution equipment that is connected to the load side of the feeder and contains branch circuit overcurrent protective devices that supply the location specified. Now, if I didn't know what the actual definition of a branch circuit overcurrent protective device, and if that's the way they're intending that to be used, then I would say, well, that could be any overcurrent protected device that's protecting a feeder or a branch circuit, right? But you really have to consider, is that what they mean? So, but in any case, the term and how it's used throughout the code is coming into question, especially in light of saying that that device protects more than just what it's specified in the definition, defined terms. All right, so I think I fixed this. Yes, finally fixed it. Jeez, oh man. All right. So in any case, so I did a quick search. Now, so here's the thing. We are taking a look at this definition for branch circuit overcurrent protective device. And there we go. Much better. So we are going to take a look at this definition, and we have two proposed, our task group met, and we have two proposed revisions. One revises the name of this product. Instead of a brand circuit overcurrent protective device, we're going to provide an overcurrent protective device, a generic term. And then we said that we use the term overcurrent protection, and it's not defined in the code, so we wanted to define that as well. Now, some terms to keep in mind, to think about, that are in the code. We have the definition of an overcurrent. That's any current in excess of the rated current of equipment or the ampacity of a conductor. So we're talking equipment and conductors in this definition of what an overcurrent is. That could result from an overload, short circuit, or a ground fault. Now remember, too, that ground faults can be short circuits. Not all ground faults are going to be are going to result in an overload of the circuit. Does that make sense? You catching what I'm throwing? If, for example, say I'm on a 200 amp circuit and my ground fault current is 10 amps, it's not an overload because 10 amps does not exceed the rating of the equipment. It is a ground fault, but it may not be an overcurrent. Do you see what I'm saying? Because an overcurrent is any current in excess of the rated current of equipment or the ampacity of a conductor. If I have a 200 amps worth of conductor and I have a ground fault that's pulling 10 amps, I'm not an overcurrent. I am a ground fault. All right. And we have specific technologies to detect that. Ground fault circuit interrupters, special purpose ground fault circuit interrupters, ground fault protection of equipment, could be a relay, could be a circuit breaker, electronic trip units. It's not an overload. Now I got to go and see what comments that just generated, because I'm sure. Where is my? Man, I am discombobulated today. There you are, Michael Hofkin in the house. All right, so Lou Petrucci, thanks for joining in. First generation American Croatian, Eli. Cool, excellent. My fellow Croat. David Engelhart. Adam Engelhart, my grandfather came in the U.S. from Poland, where he was 18. Excellent. I had a PI on this issue, but it was rejected with a panel comment that definitions come from the product standard. Dawn, we're fixing that one because we're probably going to be changing the product standard as well. So stay tuned. Stay tuned. 3 parts to overcurrent, ground fault, and overload, or any of 3, right? Yes. So remember, there's 3 parts to that ground fault of an overcurrent. If we take a look at overcurrent, any current in excess of the rated current of equipment or the ampacity of a conductor, it may result from overload, short circuit, or ground fault. So any one of those, if it's an overload, it's an overcurrent. If it's a short circuit, it's an overcurrent. A short circuit may not be an overload. And same for ground fault, all that good stuff. All right, so very important piece of that puzzle. Thanks, Robert. Michael Hofkin, 235, not 225. I'm not sure what that is. Would adding the term conductor to the definition help? Service feeder, branch circuit, conductor. Here's the... well, I'm going to show you where we're going in a second, but I love the comments. I think the use of the ground fault in this definition is intended to be a high current fault like a short circuit. Correct, Dawn. You're absolutely right. But it's a very important detail because we have to understand the fact that ground faults can be less than the rating. And hey, Nihad, we got Canada, my Canadian friend. I like the approach that the task group is taking. Okay, well, let's talk a little bit more about another. These are the 2 terms. you have overcurrent protection, automatic interruption of an overcurrent. So that's, I gotta close that. That's an important piece of the puzzle. So the first change, the first proposed change is the term up at the top, overcurrent protection, saying it's an automatic interruption of an overcurrent. An overcurrent is a defined term, so it's very simple. It's 1, 2, 3, 4, 5 letters, 5 words, 5 words, very simple definition. It says automatic interruption, so it's not manually done. So it's an automatic interruption of an overcurrent. Now, there's the generic term overcurrent protective device. Now, it's really important that we get this right, and I'll tell you the journey and what you're going to help me with today. The definition is a device capable, and remember, this is all fluid. None of this is set in stone. This is just task group work. We're spitballing and trying to make sense of how do we make some changes to help add clarity to the code. So this is all just fluid, nothing set in stone. Our goal is to say, what's wrong with this? Does it work? If it works, then we have to use it correctly in the National Electrical Code. And what my goal is today, to get back to our chair, David Williams, I've got to look at various articles and sections in the code where we either use the term overcurrent protective device or overcurrent device or whatever, and make sure that this definition fits and works. Because if it doesn't work, then you have a couple options. One, we change the requirement where we're using the term. Two, we change the term itself or the definition. Or three, drop back and punt, right? But remember, all of this began with the definition of overcurrent protective device. That branch circuit overcurrent protective device, we're hoping, crossing our fingers, that we can replace that with just overcurrent protective device, which is a device capable of providing protection over the full range of overcurrent between its rated current and its interrupting rating. Now, where did we come up with that? A device capable of providing, let's take this. Let's take the Control-CV. Let's just take this. And what we're going to do is we're going to say, what is the change? Overcurrent protective device. We're getting rid of all of this. Let's make it red. Put a strike through it. And we're getting rid of this. Make it red. Put a strike through it. And we're replacing that with OCPD. So that's the first change. The second change, a device capable of providing protection for, and we're getting rid of service, feeder, and branch circuits and equipment. We're getting rid of all of this. Make that red. Put a strike through it. Don Gannier. A device capable of providing protection over the full range of overcurrents between its rated current and its interrupting rating. That's all we did. So we removed the reference to branch circuit, feeder, and service because the application doesn't matter. What we were concerned, what we wanted to, what the task group is thinking is we want to demonstrate or convey the fact that the overcurrent protective device has an overload region and an instantaneous region of the trip curve. We want to provide that complete protection from overcurrents between its rated current. So if it's a 200 amp breaker, that top portion of the curve is 200 amps, all the way to the interrupting rating. So that covers the entire range, which would include the overloads. And it's the language that's in the definition. So you can't say, well, I don't like the full range. Well, it's been in there. If you don't like that, then we can fix that. But that means you don't like the current definition either, right? So now I'm not saying the current definition is bad, is good. It's great. I agree with Dawn that it does have some, it needs some love, so to speak, right? Dawn says the code has an issue with the term ground fault as it includes faults from milliamps through thousands of amps. Any change will have to maintain the clarity between OCBD. Oh, yes. So, where's my Word document? What he's talking about is there are two other terms that we have to think about. All right, two other terms that we need to think about. Very good point, Mr. Gannier. And let me show you something. Okay, so there's I would say you had supplementary, right, Dawn? There's also another term which is current limiting overcurrent protective device. That is another important term that we can't lose sight of. And I'm going to put those up on the screen. I'm putting those on the big screen for us. Okay. So this is current limiting. So this is the current limiting, I can't talk. This is the current limiting overcurrent protective device, a device that when interrupting currents in its current limiting range reduces the current flowing in the faulted circuit to a magnitude substantially less than that obtainable in the same circuit if the device were replaced with a solid conductor having comparable impedance. I am less smarter for having read it. I think this one needs a lot of work as well, but that's not the point today. So that is the current limiting overcurrent protective device. There's also a supplementary overcurrent protective device. And Dawn, to your point, what the task group is thinking and where my head's at, as well as even I sent a note to some of my internal people in my overcurrent protection business, and Joe Pavia came back and pointed out exactly the same things that we were talking about, some of the same stuff that I'm seeing here. We've got to make sure that we don't permit the use of a supplementary overcurrent protective device where it shouldn't be used, and make sure that the distinction is driven between the two. The fact that we have a definition and then we have requirements in the back of the code somewhere, those requirements, when they use the right term, makes sure that you use the right device for the application. Make sense? You're buying what I'm selling, okay? You catching what I'm pitching, right? So what we have is a failure to communicate. What we have is, let me just do a overcurrent protection automatic. I'm just making the language bigger that we're talking about, and I'm focusing it. So what my job is, in the process of this task group, we sort of tentatively agreed on some language. We said, look, we feel relatively comfortable that that this definition just might do the job for us, okay? So we think that this definition just might be what the doctor ordered, so to speak, and a device capable of providing protection over the full range of overcurrent between its rated current and its interrupting rating. Then what we're going to do is I've got to go back into the code, and I'm going to try Article 690. I'm going to start there. And I'm going to look at areas of the code where that term is used, and we're going to beat it up. We're going to test out the language that the task group seems to try to definitely want to use, right? Caught and confirmed. So Don Gannier, so a misapplied breaker, one in a circuit that has more available fault current than its interrupting current, would no longer be an OCPD. No, that would be a misapplication. You're right. You know what, Don, you're absolutely right. It would become a bomb. Okay? It's no longer an overcurrent protective device because you're applying it outside of its rating. It will explode probably and give you a big boom and all that jazz. It becomes it becomes something that is what's the term? Ungood. Okay? And I can show you what that looks like. I have a video of that actually. When you misapply a circuit breaker beyond its interrupting rating, and I thought I did. I know I have one in here. Let me just do a search. Interrupting. I don't know if I can show it. Nope. Anyway, I thought I have it in a different presentation and I would show it to you. But Dawn, I would say that if you, yes, Eli, it achieves an unintended rapid disassembly in the field, an unscheduled rapid disassembly. Thank you. You know what? You guys are awesome. You guys are awesome. You are definitely awesome. Anyway, man, that is just too funny. So we're going to go to 690. So what I have to do, what my job is, and what I want to bring you in on is that we have to test this definition out. So I'm going to go to Article 690 and I'm going to search for, I'm using NFPA link, and if you don't have NFPA link yet, you need to get it. I'm telling you, I was a hater, and I'm a lover now. I love the program. I love its capabilities, and yes, can it improve? Yes, everything can. You can. I can improve. We all can stand for some improvement, but I'm telling you, it's the cat's meow. So I searched for branch circuit overcurrent protective device in Article 690, and the term is not used. I'm going to search for overcurrent. I'm going to search for overcurrent protective device in 690, and it's not found. I'm going to search for overcurrent device in 690. There we go. These are all of the places we have overcurrent devices. Can be either supplemental. Ooh. Oh, look at this. 690.9b. The overcurrent devices. The overcurrent devices? That's bad English. Overcurrent devices can be either supplemental or branch circuit devices. They didn't even use the proper term. They should have said branch circuit overcurrent protective devices. So they use it in 690.9. So here's what I'm doing. So here's what I'm doing. I'm just going to give you a for instance. I am going to be clicking on those links. And 690.9 is overcurrent protection. So what I am going to do for my task group, I'm going to take that language. I'm going to put this in a Word document, and I basically am going to highlight where we use the terminology. And so here's the thing. The opportunity that lies in front of us. is as we're going through this process, just a word of advice, as we go, if you're involved with task group work or whatnot, when you put your items together, this work together, don't lose the work, right? I tell you what, people ask me how I get done all the stuff I get done. And one of my words of advice is efficiency. The fact that I am getting my task group work done while I'm doing this, I'm getting two things done at the same time. I'm contributing to the development of the National Electrical Code. I'm also contributing to IAEI and their initiative and drive to educate. So now, when you can do multiple things at one time and kill, or I don't like to say kill two birds with one stone, because I like birds. I'm a bird guy. I don't know about you. I like robins. I like red birds. I like pigeons. I like them all. I like birds. I do like to eat birds too, but I'm not talking about that. I don't want to kill two birds with one stone, because I would never throw a stone at a bird. But I want to break two windows with one rock. That would be fun. So in any case, what you want to do is I'm going to take in 690.9. I'm going to look at where the terminology, how the term is used. It says PV system, DC circuit, and inverter output conductors and equipment shall be protected against overcurrent. Piece of cake. Circuits sized in accordance with 690.8A2 are required to be protected against overcurrent with overcurrent protective devices. I searched for overcurrent protective devices. Overcurrent protective device. So we have the use of the term overcurrent protective devices. That is overcurrent protective device. That's our defined term. So we use the term right here in 690.9. Circuits, each circuit shall be protected from overcurrent. Shall be protected against overcurrent with overcurrent protective devices. And if I look at our definition, an overcurrent protective device is a device capable of providing protection over the full range of overcurrent between its rated current and its interrupting rating. Now, the importance and significance of eliminating branch circuit and feeder out of here is because if you talk to the panel 4 people, they'll tell you those conductors are not branch circuits, those conductors are not feeders. And they're not service conductors, but we settled the service argument, okay? But the feeder is still out there. So they redefined the conductors in a PV system. And now, with this change, the term overcurrent protective device does accurately apply for those photovoltaic systems. Yes! That is poetry. I'm loving it. All right. So, Robert, you are contributing to the advancements and knowledge of many of us. Excellent. Thank you, Robert. We try. We're doing the best we can with what we got, which ain't much. All right. So the first place we find this is in 690.9A. Circuits where overcurrent protection is not required. So overcurrent protection. We have a new defined term, overcurrent protection. Remember, overcurrent protection is automatic interruption of an overcurrent, period. So if I look at the language in 690.9, and I'm using NFPA link, I'm telling you, if you ain't got it, you ain't nothing. You got to get this. This is an awesome program. 690.9, overcurrent protection. We already identified right here, overcurrent protective devices. That's the term that we just defined. And we have overcurrent protection. We have shall be protected against overcurrent. Where overcurrent protection is not required, Overcurrent protective devices shall not be required where both of the following conditions are met. So that's another use of the term. Overcurrent protective devices. I wouldn't change a thing there. All right. The conductors have sufficient ampacity. Circuits where overcurrent protection is required, and that's, again, another defined term. And proper use of that term, I might add. Thank you. Overcurrent protection. I'm just highlighting overcurrent protection, the defined terms. All right. Oh, got another one here. The currents from all sources do not exceed the maximum overcurrent protective device rating. Still works. I'm here to tell you. Thank you. Overcurrent protective device rating. Specified for the PV module or electronic power converter, so that's good. The circuit conductor connected at one end to a current limited supply where the conductor is rated for the maximum current rating, also connected to sources having the maximum available, shall be protected from overcurrent at the point of connection to the higher current source. So I think I get the point. All right, so I'm not seeing anything else. Oh, there's another use of the term overcurrent protection, and that's a proper use. So what I'm doing is I'm looking at existing language in each of these sections where we use terms for an overcurrent protective device or overcurrent protection, and I want to validate that against the definition that we developed. All right. Get your water and your beverage of choice. All right, so I think I get the point. So how about device ratings? Ooh. Did I get device ratings? I got A. Nothing else in A. Here we go. Control C. And we are going to need a change, and I'll show you what I'm talking about. So here is, every now and then we get a little crazy, but we also get a little lazy. And this is a picture of laziness. Overcurrent devices used in PV source circuits shall be listed for use in PV systems. That could say, or probably should say, I'm going to do a review, check changes. I'm checking changes. Overcurrent protective devices used in PV source circuits shall be listed for use in PV systems. So that would be a better use of, that would be the proper use of the term. Electronic devices that are listed to prevent backfeed current in PV system DC circuits shall be permitted to prevent overcurrent of conductors on the PV array side. Overcurrent devices, that should be overcurrent protective devices, where required, shall be rated in accordance with one of the following and permitted to be rounded up to the next higher. And it says overcurrent devices, I'm going to say overcurrent protective devices, shall be rated not less than 125%. And assembly, together with its overcurrent protective devices, that is listed for continuous operation at 100%, blah, 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 blah. All right, so what I'm recognizing is we're using the term correctly. We got a little lazy and didn't have the word protective in there, so I'm adding that in. So what I'm doing is, you know what I'm doing? I'm creating public comments for our task group. So as a part of this process, we want to take and look at the code, ensure that the right term is used, the definition that we've come up with doesn't conflict, and identify these are going to be public comments. And I'll get these over to David Williams as chair of the task group, and he will share these with the task group and say, hey, all right, Tom looked at 690, and I'm not done yet, and found these are the locations where we're using the term, and he is suggesting these changes. And if the task group, if it passes the smell test, then we'll make, as a task group, a public comment for the National Electrical Code. And when you see it as a public comment, you'll see David Williams submitting the public comment on behalf of our task group. And as long as what I'm looking at here is agreed upon by more than just moi, then we're improving the code. Make sense? I hope it makes sense, because if it doesn't make sense, then are you contributing? In section 210.18 should also be corrected to say setting of overcurrent protective device. Well, we're going to get to 210. You know what? I should have started in 210, Don. Page 83. In 690.9b, should the next standard size reference? Don Ganir. In accordance with 240.4b. The following and permitted to be rounded. Oh no, hold on, Dawn. So here's the issue. The next higher standard overcurrent device rating shall be permitted to be used. This is when you get to 800 amps or less. So the language, it says overcurrent devices where required shall be rated in accordance with one of the following and permitted to be rounded up to the next higher standard size in accordance with 240.4b, which tells you where you can't round up to the next size. Capiche? Make sense? I like where your head's at though, Dawn. You're thinking. All right, so there's a C here too. I just got to make sure. I gotta turn the track changes off while I do this. Single overcurrent protective device. So in C, we're covered. For PV system DC circuits, a single overcurrent protective device where required shall be permitted to protect the PV modules. So that's good. Overcurrent protection, where single overcurrent protection devices, that needs to be where single overcurrent protective devices are used. What does that mean? They're not married? What does that mean? Where single overcurrent protective devices are used to protect circuits, all overcurrent protective, they say overcurrent devices, overcurrent protective devices, I hope you're following along in your code book, shall be placed in the same polarity for all circuits within a PV system. The overcurrent, not overcurrent devices, the overcurrent protective devices shall be accessible, but shall not be required to be readily accessible. All right, so what we did was we just took 690.9c and we just added the word protective to use the proper term, and I don't see anything in there that would be a conflict. Let's look at D. Overcurrent protection for power transformers shall be installed in accordance. So here's my thought on this one. Overcurrent protection for power transformers shall be installed in accordance with 705.30F. In my opinion, and I'm going to put this in, you may or may not agree with it. I'm going to say overcurrent protective devices for power transformer overcurrent protection, protection shall be installed in accordance with 705.30F. That's, I think, much clearer. Instead of saying overcurrent protection for power transformers shall be installed in accordance with 705.30F, I'm going to suggest overcurrent protective devices 4, power transformer overcurrent protection shall be installed in accordance with 705.30F. Tell me that doesn't sound much better. I mean, don't tell me that doesn't sound much better, because I think it sounds much better. In section 690.9b, in every place used in 1 and 2. Overcurrent devices. Oh, man, did I miss that one? Overcurrent devices. Yeah, I got overcurrent protective devices shall be rated. And then, yep, so I got that, Dawn. We are golden. And I believe we've got all of the areas that we need to clean up, and nothing in 690, in my opinion, nothing in 690.9 and the way we use the term conflicts. So I'm going to go back to a search. Overcurrent devices in 690.8D. 8D. It says where an over, oh yes, 690.8D. Well, I'll be a horse's patoot. 690.8D. So I'm gonna put this in there. And I don't believe track changes, Control V, A, B, C, D. This is your multiple PV string circuits. Multiple PV string circuits. It says where an overcurrent device is used, and I'm going to say an overcurrent protective device is used to protect more than one set of parallel connected PV string circuits. The ampacity of each conductor protected by the overcurrent protective device, OCPD. Oh man, we can use the acronym. There, Dawn, that just opened up a whole nother world. I could just say OCPD. Oh man, Dawn, this just opened up a whole nother world. The rating of the overcurrent protective device, or OCPD, the sum of the max current for other parallel, blah, 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 by the overcurrent protective device. So what I'm seeing in 690 is in some applications, they used overcurrent protective device. In some, they just said overcurrent device. I'm thinking that we're still good with the definition. 690.9b, 690.8, 690.4 equipment, 690.4 general requirements. B is equipment, electronic power converters, motor generators, PV modules, AC modules and AC module systems, DC combiners, PV rapid shutdown, blah, 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 DC circuit controllers, and blah, 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 used in PV systems shall be listed or evaluated for the application of, well, where is, it might be, where is it? Equipment. It's instructions for or labels on the PV module might require additional. That's in the enhanced content. So that's not a part of the positive text. 690.31C, 690.31. Let's move. 690.31C. 690.31 is what? 690.31 is wiring methods. So 690.31, go into my Word document and take off track changes, Control V, 690.31C, as in Charlie. I'm going to have to go back to search. C1, single conductor cable. C1, single conductor cable. Single conductor cable in exposed outdoor locations. Exposed cable supported strap outdoor. Nope. I am not seeing it. 1,000 points of light. Go back to search. And it says constants in DC can result in proper. Oh, you know what? That's in the enhanced content. So I'm not fixing the enhanced content. 690.7a, photovoltaic sources and output circuits. Adjust the maximum before conductors, overcurrents, and switchgear are selected. Nope, that is enhanced content. So we got everything at 690. No other areas in 690 are impacted, and that means that we only have 2 sections, but we do have areas that we need to address. So 690 looks good. Let's look at 240. Now 240 is going to be, oh man, 240 overcurrent protection. So I'm here's what I'll show you what I'm doing. I'm in 240. I'm looking at overcurrent device. Ooh, look at this. 240.4b, overcurrent devices, rated 800 amps or less. And if I say overcurrent protective devices, rated 800 amps or less, perfectly fine. Perfectly fine. Article 310 does not match the rating of the standard overcurrent protective device. So 240.4 is going to need to be looked at. I don't believe there's any issues there. 240.24a, accessibility. Overcurrent protection devices, that should be protective devices, may be necessary in locations that are not readily accessible, such as above suspended ceilings. Now, here's, okay, 240.24, guys and gals. 240.24. Location in or on premises. This says circuit breakers and switches containing fuses shall be readily accessible. Well, now, when I say circuit breakers and switches, that can be any circuit breaker or switch. It can be a branch circuit overcurrent protected device as it's defined today. It could also be a supplementary device. It could be a current limiting device. It doesn't matter. It just says circuit breaker. If a circuit breaker, period, I don't care if it's supplementary, the type does not matter. The fact that it contains a fuse does matter. So circuit breakers and switches containing fuses shall be readily accessible and installed. So that's in 240.24a. I need to get my comments up here. I'm not watching the comments. Oh boy, Nihad. All right, I saw the Nihad agreed. Okay, hold on. Does it have to be spelled out in the first use? Yes, Dawn, I believe. So here's my opinion. And if you don't have an opinion, all you got to do is ask, I'll give you mine, right? And anybody in Codes and Standards has an opinion. So here's my opinion, Dawn. I think that in each article, you should use the term, show the acronym, and then you can use the acronym from hence on. Saying it's in Article 100 and the acronym is defined there, I don't like that. Because you got to go hunting and pecking too far. In fact, you know what I think would be a cool addition, Dawn? Imagine this if you would. An article or a section, maybe in 110, that just has a list of acronyms. OCPD, GFPE, GFCI, AFCI. I'm sure we can come up with a bunch of other acronyms. That would be a sweet addition to the code, and I look forward to your public input. Education Power, Robert from Omaha. That's the way we talk anyway, right? Less confusing. That's true. Section 235.20a. All right, so you're in 230 and 235. I'm going to 240. So 240.24 for overcurrent protective devices, as described in 225.40, 230.92. So 240.24 uses overcurrent protective devices. I don't see any problem with that. And supplementary, look at this. You know what? I ain't gonna do it. 1,000 points of light. Here we go. Look at this. It says, for supplementary overcurrent protection, as described in 240.10, supplementary overcurrent protection. Circuit breakers and switches containing fuses shall be readily accessible and installed so that the center of the grip of the operating handle of the switch or circuit breaker, when it's in its highest position, is not more than 6 foot 7 inches above the floor. unless one of the following applies for supplementary overcurrent protection, as described in 240.10. If we click on that, supplementary overcurrent protection, where supplementary overcurrent protection is used, and I would say this should say where supplementary overcurrent protective devices are used, right? Because that's what we're really talking about, a supplementary overcurrent protective device, and that's a defined term. So I think that needs to change, 240.10. Appliances and other equipment for internal circuits and components of equipment, it shall not be used as suitable for required branch circuit overcurrent devices. They didn't even use the term. Or in place of the required branch circuit protection. I would say as a substitute for, we need to focus on, this is where the challenge in what we're doing lies. So this is a good one. This is a good one. I got to put this one in my Word document because if you would ask me where's going to be the biggest challenge is differentiating between the branch circuit, what we used to know as the branch circuit overcurrent protective device, and a supplementary overcurrent protective device. What's 225.40? Access to overcurrent protective devices. Where a feeder overcurrent protective device is not readily accessible, branch circuit overcurrent devices shall be installed on the load side, shall be mounted in a readily accessible location, and shall be of a lower ampere rating than the feeder overcurrent device, 225.40. That needs work. So what if the feeder overcurrent device feeds a panel board that has nothing but feeders in it, or has one branch circuit overcurrent device and the rest are feeders? Where a feeder overcurrent device is not readily accessible, branch circuit overcurrent devices shall be installed on the load side, shall be mounted, shall be installed on the load side, shall be mounted in a readily accessible location, and shall be of a lower ampere rating than the feeder overcurrent device. Tell me that's not confusing. We need to clean that up. And with the new terminology, I think that will become much cleaner and simpler. So that is a target, 225.40. 225.40. How about 230.92? Where the service overcurrent devices are locked or sealed or are not readily accessible to the occupant, branch circuit or feeder overcurrent devices. Oh, I love it. There's the epitome of why we're doing what we're doing. Right here, copy 230.92. I think Robert from Omaha, I think you identified 230.92 in your comments. You gotta love it. Nihad is spelled out in the title of 210.8 and in the title and the text Nihad. Do we spell out GFCI? And yes, we do. It's in the title. Thank you, Dawn. You're absolutely correct. We did that in 210.8 and 210.12. We put the acronym. I like that. I like what we did on panel 2 even better. You put the acronym in the section title and then you use it in that section. That's really nice. All right, so I've identified, we've got 240.10. We've got to make sure that's clean. 225.40 needs a lot of love. Oh my gosh. I mean, you need a lot of love in 225.40, where feeder overcurrent, 230.92, Dawn, look at this one. 230.92, locked service overcurrent devices. Where the service overcurrent devices are locked or sealed or are not readily accessible to the occupant, branch circuit or feeder overcurrent devices shall be, what's a feeder overcurrent device? Shall be installed on the load side, shall be mounted in a readily accessible location, and shall be of lower ampere rating. And I'll tell you what, that needs to be broken off into list items. It's putting list items in there, and it is an epitome of why we're doing what we're doing. So 230.92 is another good. Did I do 240.10? So how about 368.17c, where a busway is used as a feeder, devices or plug-in connections for tapping off feeder or branch circuits from the busway shall contain the overcurrent devices. 368. Oh man, we are in a target-rich environment for fixing the use. And I have not seen any place yet where the definition, the term and its definition that we created in the task group would conflict with the requirements. I'd love your opinion on that. So you know where my head is at. So here's my ask. Here's my ask. Cheers. As you look down through the code, I'm going to throw this up on the screen again. This is the defined term that we are considering right here. Overcurrent protective device, a device capable of providing protection over the full range of overcurrent between its rated current and its interrupting rating. As you navigate the code, take a look at where we're using the term overcurrent device, overcurrent protection devices, overcurrent protected device, branch circuit overcurrent protected device, branch circuit overcurrent device. Everywhere where we use something that this term needs to be used. If you find issues, send them to me. If you have a conflict, if you think there's an issue, if you think we're creating a problem, I need to know about it. I really do. And the task group will appreciate your efforts. And this is your opportunity to engage in the development of the National Electrical Code. You see what the task group is working on. Fully transparent. The process is fully transparent. And we need to determine whether or not what we're trying to do here is helping things, or is it hurting things? So take a look, and we've identified a few areas. So what we did today was we went through 690, went through in the entire article. 690.8, we've got opportunities for fixing some issues or just adding clarity, no conflict. 690.8, 690.9, overcurrent protection. We also looked at 240.10, 225.40, 230.92, and 368.17 Charlie. In 368.17 Charlie. So each of those, I think I've got some work to do in 240.10, 225.40, and 230.92. Those three sections are going to need some work. Where a feeder overcurrent device is not readily accessible, so saying overcurrent protective device is not readily accessible, piece of cake. It says branch circuit overcurrent devices shall be installed on the load side. I would say overcurrent protective devices shall be installed on the load side. And I would put this into a list. And anyway, I'm going to work on this. I am going to work on this. But you see what we're doing. And I hope that this session gave you some insight to the use of terminology in the code, the significance of participating at the table, or in some fashion, I'm giving you that opportunity. Armando Cepeda, greetings from New Mexico. Thank you for joining in. Hopefully New Mexico is cooler than it is in Weirton, West by God, Virginia. But I hope you got something out of, so you can have a case where a feeder overcurrent device supplies another feeder overcurrent protective device. You're absolutely right. You are absolutely right, Dawn. That's why it's really important. But in both cases, they are just overcurrent protective devices, right? What they're protecting, if you need to add the clarity on what they're protecting, then you would do that in the code. So you got to be careful in the language. What this is doing, here's the thought process. What this is doing is causing us to look at something that is so simple, yet you start to realize how complex and complicated it is. And then once you really start to look at it, you realize how screwed up the current the terminology is and how you're using it. But somehow, we're not burning down buildings, right? So we don't want to break what good is happening right now. We want to enhance it. All right. So Steve Froming, thank you for joining. Mr. Wages, Jody Wages, thank you for joining. Robert from Omaha, I love the passion. Send me your notes. Send me any of these areas where you are finding some challenges. And I appreciate everything that all of you do for the electrical industry and electrical safety. If you're watching this right now, you are one of those individuals. You are one of those people that motivate me to do what I'm doing. So I enjoy every session that we have, and I'm looking forward to many more. And growing the YouTube channel. So remember, this YouTube channel is going to go on steroids. I am working with Paola down at the international office, and we're coming up with the plan. We're going to have subscriptions. We're going to have the ability to have paid content. We're going to bring more educational opportunities and differentiate this YouTube channel from anything else. So I look forward to doing and seeing you here on this YouTube channel for IAEI. Thanks, Don Gannier. You are the man. Eli Markovich, thank you very much. Robert from Omaha, Jody Wages, Steve Froming, Armando, Nihad, and everybody else. God bless, take care, stay safe, and please stay healthy. David Engelhardt, don't forget, smash that like button. See you next week.